In today's lesson, we are going to learn about buffers. What is a buffer solution? Before that, let us take a look at a short clip. There are two solutions A and B, which has been added with universal indicator. Here's the reference chart. As you can see, both the solutions are around pH 6 or very slightly acidic. Now, concentrated sodium hydroxide, a strong base, is going to be added to each solution. It only took one drop of strong base to dramatically raise the pH of solution A. After one drop, the pH of solution B did not change. Let us restart. Here are the same two starting solutions A and B with the same indicator, but this time concentrated hydrochloric acid, a strong acid, is added to each solution. It only took one drop of strong acid to dramatically lower the pH of solution A, but the pH of the other solution B has not changed. Let us look at the pair of solutions again. When strong acid and base was added to solution A, its pH changed dramatically after just one drop. When one drop of acid and base was added to solution B, its pH stayed the same. Let's see what happens when more acid and base is added. It takes much more acid and base to change the pH of this solution by the same amount. Now, how is solution B able to resist changes to its pH when strong acid or strong bases are added? In this lesson, we will learn about it, which explains the nature of buffers. Buffer solution is a solution that has the ability to resist changes in pH upon addition of small amounts of either acid or base. A buffer solution must contain an acidic component and a basic component. A buffer solution contains a weak acid and its salt, or called conjugate base, or a weak base and its salt, called the conjugate acid. Let us look at examples. A mixture of weak acid and its conjugate base forms an acidic buffer. For example, the mixture of ethanoic acid and sodium ethanoate. The acidic component is the weak acid ethanoic acid, and the basic component is the conjugate base ethanoate ion. A mixture of a weak base and its conjugate acid forms a basic buffer. For example, the mixture of ammonia and ammonium chloride. The acidic component is the conjugate acid ammonium ion, and the basic component is the weak base ammonia. An acidic buffer solution can be prepared by mixing a weak acid and its salt or the conjugate base. For example, ethanoic acid and sodium ethanoate. The reaction that occurs in the buffer solution is the partial dissociation of the weak acid ethanoic acid to form ethanoate ions and hydrogen ions, and also the complete dissociation of the conjugate base sodium ethanoate to form ethanoate ions and hydrogen ions. Therefore, there will be an equilibrium in the buffer solution that exists between the weak acid ethanoic acid, the conjugate base ethanoate ions, and hydrogen ions. Let us now study the mechanism of a buffer solution and how it controls its pH. What do you think happens when a small amount of strong acid is added to the buffer solution containing a weak acid, ethanoic acid, and its conjugate base sodium ethanoate. The hydrogen ions from the strong acid added will be neutralized by the ethanoate ion, the conjugate base, to form ethanoic acid, the weak acid. During the course of the reaction, the hydrogen ions are removed and the base ethanoate ion forms the weak acid, ethanoic acid. In this way, the concentration of hydrogen ions in the solution remains constant. As a result, there will be only a small change in pH, and the concentration of the ethanoate ion decreases while the concentration of the weak acid, ethanoic acid, increases. A similar reaction takes place when a small amount of strong base is added to the buffer solution. The added hydroxide ion from the strong base will be neutralized by the weak acid, ethanoic acid, to form the conjugate base ethanoate ions and water. It is seen that the hydroxide ions is being consumed. As a result, there will be a small change in pH and the concentration of the ethanoate ions increases while the concentration of the weak acid, ethanoic acid, decreases. As we have previously learned about acidic buffer solution, now let us look at the basic buffer solution. A basic buffer solution can be prepared by mixing a weak base and its salt or its conjugate acid. For example, is ammonia, the weak base, and its salt ammonium chloride. The reaction that occurs in the buffer solution is the partial dissociation of the weak base ammonia to form ammonium ions and hydroxide ions, and also the complete dissociation of the salt ammonium chloride to form ammonium ions and chloride ions. Therefore, there is an equilibrium that exists in the buffer solution between the weak base ammonia, the ammonium ions from the salt, and also the hydroxide ions. Let us study the mechanism of the basic buffer solution and how it controls its pH. If you remember, we have already studied how an acidic buffer solution controls its pH. The reactions will occur in a similar manner. Now, what will happen if a small amount of strong acid is added to the basic buffer solution of a weak base ammonia and its salt ammonium chloride? Yes, the hydrogen ions from the strong acid added will be neutralized by the weak base ammonia to form the conjugate acid ammonium ions. Since the added hydrogen ions have been neutralized, therefore the concentration of the hydrogen ions in the solution remains constant. As a result, there will only be a small change in pH, and the concentration of ammonia, the weak base, decreases, and the concentration of ammonium ions will increase. Now, Predict what will happen when a small amount of strong base is added to the basic buffer solution. Yes, the added hydroxide ions from the strong base added will be neutralized by the ammonium ions which act as the conjugate acid to form the weak base ammonia and water. Since the added hydroxide ions have been consumed, there will only be a small change in pH, and the concentration of the ammonium ions, which is the conjugate acid, decreases, and the concentration of the weak base ammonia will increase.